SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering basic and applied, and today we shall discuss about the boiler attachments. If we try to recall, in the last two classes we have discussed about the fire tube and water tube boilers, and we have seen the working principle, rather the operation of the boiler. In particular, since boilers are used to generate steam, we had identified two different streams, rather flow path. One is this rather cycles, steam water cycle, another one is the coal and the combustion or products of the combustion cycle. In the context of the boiler attachments, we shall be discussing again, rather we shall try to group those components into two different categories. One is known as mounting, another is known as accessories. So, if we try to write boiler attachment, and this is having mountings, sub classifications, that is mountings, and another sub classification is accessories. So, you can understand that basically the components which we have discussed in last two classes, those are essential components essentially for the operation of the boiler. Now, if we try to figure out which are the components responsible for the safety operation of the boiler, and there are a few components which are not directly related to the safety of the boiler and its operation, but still those components are required for the efficient operation of the boiler. So, now let us discuss about this part briefly. So, when we talk about boiler operation, all these components are attached to the boiler essentially to ensure that boiler operation should be safe. So, safety point of view, a few components will be needed, while for the efficient operation of the boiler, we also will be required a few components. Mountings these are the components, basically these are mandatory component, for boiler operation. Right. These components, they do not directly affect the boiler performance. Boiler performance, right, but as I told you, so there are a few components which are mandatory components for the boiler operation, and without these components no boiler is certified. So, mountings, no boiler is certified without mountings. Okay. So, these are mandatory components. Basically, a boiler should have all these components. They do not directly affect the boiler performance, but basically these components are used for boiler and its operator, safety. Example, water level indicator, pressure gauge, right, feed check valve, fusible plug, etc. So, these are the mountings. One important thing is, though someone may argue that since these components are not needed, because these components may not be needed because they do not directly affect the boiler performance, but still these are required, because this point is very important, because we need to ensure that safety of the boiler as well as the operator of the boiler should prevail. So, while boiler is in operation, and to ensure that mountings are mandatory and no boiler is certified without mountings. Next, we are going to discuss about accessories. Accessories, these are not mandatory. Component. Okay. But these components directly affect the boiler performance. These are not mandatory, because a boiler can be certified even without accessories, but this particular components are needed because they directly affect the boiler performance. If we go back to the previous slide, here we have discussed about this particular issue. So, this classification, because boiler attachment, let me tell you once again. So, these are the components which are attached to the boiler, and that we have seen, when we have discussed about the fire tube and water tube boilers. But out of these components, a few components can be grouped together and those are known as mountings, while the remaining components or another group of another set of components can be grouped together, and this particular group is known as accessories. So, this classification is based on the fact that a few components which are there in the boiler, they directly affect the boiler performance. So, basically those are needed essentially to ensure that the operation would be efficient. Why? Because we are supplying water and our main purpose is to convert water into steam. In particular, if we try to recall the thermodynamic cycles that we have studied, we should try to get superheated steam from the boiler, right. So, to ensure that water which is circulated through the boiler should be converted into superheated steam, and to get it, this particular aspect is very much needed to be looked at, and that is called efficient operation. While safety operation is also important, because boilers are normally operated at a high pressure, and at that pressure, because boiler is essentially a kind of closed vessel type, to ensure the safety of the boiler, most importantly the boiler operator, a few groups, a few components are attached to the boiler, and those are known as mountings. So, these accessories examples include, examples are superheater, reheater, economizer, So, superheater, reheater, economizer, all these are basically the accessories. So, these are directly affect the boiler performance. You can see from the name itself, superheater we have discussed, that is convective superheater and radiative superheater. These two superheaters are placed inside the boiler, and the entire purpose of placing these components is to get superheated steam, and that is why that means we are trying to increase the efficiency of the boiler, right. Similarly, reheater, you have seen that reheat cycle we have discussed, the entire purpose is to have the entire expansion of the steam into two different stages of turbine, that is high pressure stage turbine and low pressure stage turbine. So, after doing some amount of work, steam is taken again into the boiler and the steam is allowed to pass through the reheating coil, so that steam temperature is again increased and it is again taken to the low pressure stage turbine. So, the reheater is again another accessories which is needed to increase the efficiency of the cycle. And finally, economizer, though this word I am introducing today, I will discuss today the purpose of this particular component in the context of the boiler operation. So, these are the accessories. So, now let us briefly discuss about the accessories. So, that we have discussed that superheaters, whether it is a convective superheater or it is a radiative superheater, these two superheaters are placed inside the boiler, because the steam which we are getting from the turbine from the boiler is saturated. Even if it is saturated steam, we need to take that saturated steam through the through these superheaters to make to get the superheated steam at the exit of the boiler. What about reheater we have discussed? Now, let us briefly discuss about the economizer. So, idea is that we have seen in the boiler, we have discussed that coal is taken and that coal is taken to the combustion chamber, wherein in presence of air coal combustion takes place. So, it is because of this combustion we are getting flue gas which is having high temperature. Even though that flue gas is taken either through the tube or through the cell, depending on the types of boiler. So it that flue gas exchange heat with the water stream, and upon releasing heat, flue gas is taken through the stack and it is it goes to the surroundings. But it is very essential that exit temperature of the flue gas should not be very high. Why? There are two different reasons. First is that if we allow high temperature flue gas, rather if we release high temperature flue gas from the boiler, so it will increase the temperature of the surrounding air. So, it is not allowed because of the environmental issue. On the other hand, that high temperature flue gas we are getting at the cost of some input energy, I mean we are getting by burning coal. So, the objective should be to utilize the temperature of the flue gas to the extent possible inside the boiler, so that the entire process can be should be efficient. So, basically the process efficiency will be increased, which in turn will increase the efficiency of the boiler. So, the objective should be not to release flue gas which will be having high temperature because of this environmental issue. Second is the temperature of the flue gas should be utilized to increase the temperature of water, even temperature of steam. Temperature of water will be definitely increased, so that it will be converted into steam, and finally temperature of the steam also will be increased, so that we will be getting superheated steam. And this utilization of high temperature of flue gas should be as high as possible, so that we can increase the efficiency of the process. One way, definitely we will be increasing the we will be utilizing the temperature of flue gas to increase the temperature of steam which is coming out from the boiler. Another way of utilizing the temperature of hot flue gas is to use of economizer. Let us briefly discuss about it. So, economizer. This is again a device, basically a type of heat exchanger you can say, and the entire purpose of this heat device is to increase. So, if we try to draw the TS plane, so we can see that so this is 2, this is 3, this is 4, this is 1. So, this is P condenser and this is P boiler, right. So, you know that this one is basically at the exit of the condenser, and that is the saturated liquid, and that is pumped back to the boiler, and this is the inlet condition of the working substance, rather inlet condition of the working substance before it enters into the boiler. Now, this so 2 to 2 prime, if we give name 2 prime, so you can understand this T2 and T2 prime. So, this T2 prime to T2, this amount of sensible heating is required initially. Idea is that if we can use the flue gas temperature which is otherwise be leaving from the boiler, and that heat we can utilize to increase the temperature of feed water, so that this sensible heating amount can be reduced. So, this is sensible heating. So, basically idea is, so this is the hot flue gas, and we also can take another stream, that is feed water. So, these two streams, whether these two streams will be taken following the counter flow arrangement or parallel flow arrangement, that is again an important issue, but the main idea is to utilize the temperature of hot flue gas, and that temperature will be taken by the feed water, so that we can increase the feed water temperature from 2 to say 2 double prime, and that is done by using another device which is known as economizer. So, economizer is again a type of heat exchanger in which these two streams are allowed to pass either following counter flow arrangement or parallel flow arrangement, that is depending on the requirement, but the main purpose is to utilize the temperature of hot flue gas which is leaving from the boiler, and taking that heat, our objective should be to increase the temperature of feed water before it enters into the boiler. So, if we can increase the temperature say now up to 2 prime before it enters into the boiler, then perhaps the sensible heating will be now T2 prime to T2. So, basically the amount of sensible heating required, given the fact that all other conditions are remaining same, is getting reduced, so that we can increase the efficiency of the boiler, and that is why the word economizer is coming. That means, we are trying to economize the entire process. Okay. So, this is all about the economizer. We can see from today's discussion that we still can use the high temperature combustion gases. We can utilize the high temperature of the flue gas to increase the temperature of feed water with an objective of economize the process. So, this is another way of utilizing the high temperature of the flue gas. Another possibility of the utilization of the high temperature of the flue gas is to increase the temperature of air, and that is called air preheater. So, in this context, let us briefly discuss about air preheater. So, air preheater, you know that air is essential for the combustion of the coal. So, when coal is taken inside the boiler, we also need to have arrangement so that sufficient air will be allowed to go therein to have efficient combustion. And when air is taken for the air combustion, for the combustion of coal, air is preheated again by having one arrangement. So, this is hot flue gas and this is air. So, the temperature from the hot flue gas will be utilized to increase the temperature of air, so that that heated air can be now taken for the combustion of coal. Using this process, the combustion efficiency will be increased. So, this is another way of utilizing the temperature of hot flue gas before it goes out from the boiler. So, these are the cases basically so basically this preheated air increases the combustion efficiency. Okay. by how? You know that if we supply preheated air for the combustion of coal, then the moisture content of the coal should be, I mean the moisture which is there in the coal will be taken by this heat or high temperature air, so that the combustion process, the overall efficiency of the combustion process will increase, and that is how this is this particular process works. So, this is air preheater, and finally, coming to the superheater and reheaters. So, coming to the superheaters and reheaters. See, superheaters and reheaters, basically again these are high temperature and low temperature heat transfer surface in the boiler. So, superheater these are high temperature surfaces in the boiler, and reheaters these are the low temperature surfaces in the boiler. So, now these reheaters are not very low temperature. So, it is better not to place it in the low temperature, rather it is still can be placed as the high temperature. So, these two are superheaters and reheaters are the high temperature surfaces in the boiler. You know that for the superheater input is saturated steam, whether it is dry saturated steam or wet saturated steam, but output is superheated steam. For the reheaters as well, you know that if we try to recall, after doing some work, steam is taken to the boiler and steam is allowed to pass through the reheating coil. So, input is again saturated steam, but output is superheated steam. Okay. So, basically for the reheater, the saturated steam is taken from the turbine. So, this is the difference, steam comes from turbine. Okay. But here steam comes from steam drum. Okay. And finally, this economizer that we have discussed in the last slide, this is low temperature surfaces. Right, because after releasing heat to the water and again to the saturated stream, the temperature of the flue gas is again further extracted to increase the temperature of feed water in the economizer. And so, you can understand the temperature. So, superheater is again a type of heat exchanger, reheater is also heat exchanger, economizer is also a surface heat exchanger. So, but the temperature at which these devices are working is not same. So, superheaters and reheaters are basically high temperature surfaces and economizer is the low temperature surfaces in the boiler. Okay. Now, basically all these are attachments. We shall be now discussing about the superheaters, because superheaters play a crucial role for the I can say the overall efficiency of the plant, because the entire objective to get the superheated steam. But before going to discuss about the classification of superheated and also their arrangement, let us also briefly discuss about another two different types of attachment, that is called regenerative heaters. So, regenerative heaters, you have seen that why I am discussing, because we are discussing about the boiler attachments. So, we have discussed about closed type feed water heater and open type feed water heater. Again, whether it is open type feed water heater or it is a closed type feed water heater, it is essentially a type of heat exchanger in which two different streams are allowed to pass. In an open type, they directly they are these two streams mixed together in that particular device. In the closed type, two different streams are not allowed to mix together. So, in these regenerative heaters, steam bleeding is done from turbine, right. So, this is regenerative heaters. And finally, another important attachment is deaerator. Deaerator. Now, I am first time introducing this word deaerator. You can understand from the name itself, to deaerate. So, to remove air, from where? So, deaerator, these are used in steam power plants these devices are used to extract dissolved air from water. Okay. And this deaerator is classified into two different categories. One is called primary deaerator, another type is called secondary deaerator. Okay. So, primary deaerator, you know that we have discussed in the condenser, we are taking air, we are taking coolant, right. So, this and condenser are operated at a pressure which is less than the atmospheric pressure. So, chances are there of having air leakage into the condenser. If air leaks into the condenser and if it mix with the condensate, so is this deteriorate the condenser performance. I shall be discussing in one of the classes of this particular course, but this dissolved air should be removed from the condenser, otherwise chances are there that in the condenser heat transfer rate will be affected, and if the dissolved air is again pumped back to the boiler, you know that air will try to create another problem from the operational point of view. So, basically you know that primary deaerators are used in condenser. So, primary deaerator used to remove air, used to extract air dissolved in steam in condenser, right. And in the secondary deaerator, you know that we are bleeding steam from the turbine, and that steam is now allowed to mix with the condensate which is pumped. So, by mixing these two different streams we can remove air. So, secondary deaerator is a regenerative heater. So, secondary deaerator is again a regenerative heater. Secondary this is basically regenerative heater. Okay. So, that means the air which is present in the condensate, as I told you that condensers are operated at a pressure which is less than atmospheric pressure. So, chances will be there of having air leakage into the condenser. If air leaks into the condenser, that air will disturb the heat transfer, it will affect the heat transfer performance by having a thin film of air in the condenser tube. And not only that, if air dissolve with the condensate, that will again create a problem when that condensate is pumped back to the boiler. So, our objective should be to remove air which is dissolved in steam in the condenser, and primary deaerators are used to serve that particular purpose. And secondary deaerator basically regenerative heater. So, condensate which is coming from the condenser is still having some dissolved air within it. So, to extract the dissolved air which is done, that steam is extracted or bleeded from the turbine, and that steam which is bleeding from the turbine is allowed to mix with this condensate, and air is removed, extracted air is removed. So, basically secondary deaerator is a regenerative heater that we have discussed in the context of open type feed water heater. So, now basically we next will discuss about the classification of superheater, and also we shall see that what are the different types of superheaters are used typically in the boiler and their arrangement. We shall discuss this particular aspect in the next class. To summarize, today what we have discussed is that we have discussed about the boiler attachments, we have tried to discuss about the objectives of several components which are attached to the boiler. These components can be grouped together, and one particular group is known as mountings, which are mandatory components. No boiler is certified without mountings, though these components do not directly affect the boiler performance, but these components are essential for the safety operation of boiler as well as its operator safety. Another components, a few components can be grouped together, and this particular group is known as accessories. Though accessories are not the mandatory components, but these components directly affect the boiler performance, and so these components are very much needed because our objective should be to increase the efficiency, to increase the process efficiency. Then we have discussed about the accessories like superheaters and reheaters. We have introduced economizer, which is again another important device in the context of boiler operation, and finally we have discussed about the regenerative heaters and deaerator, because these devices are again important for the complete operation of the boiler. So, with this I stop here today, and we shall continue our discussion in the next class with the classification of superheater and their operations. Thank you.